Hello everyone, welcome to the Automation YouTube channel. In this video, I am going to demonstrate how we can construct four-wheel differential drive robot, and after that we are going to execute around 6 experiments related to four-wheel drive. Uh, these are the experiments. That means four-wheel drive robot should move forward direction continuously and should move in reverse direction continuously, and right turn, left turn, and in fifth and sixth experiment, that is, robot will move by exact distance of 0.2 meter. That's called position control. This is called moreover like velocity control, and then this is a position control. Like the sixth experiment is like move reverse by 0.2 meter. Okay, so this is what the required output. Now let us see. Let us construct. And before construction, we are discussing like what is the output, how it should come actually. So this is a four-wheel drive differential drive robot. It has got a body and four wheels and two sensors. This is sensor 1 and sensor 2. Okay. So this is a program for obstacle avoidance that is written in C. This is a program. Fine. I'm going to demonstrate first. Run. So now it has detected an object, that is wooden box. So that is why it has turned right. Again it is going to detect another object. Range can be increased. So right now the threshold value is of the sensor is 950 is there. So avoid collision, this I will make it 300, so that very well advanced it will take the turn. Save. Build the program again. Reset. Run. Yeah, that is actually, it is too sensitive. I'm going to make it as it is 100. That is good value. Okay, so this is what the outcome. Now how to construct this body, that is robot, custom robot, and then how to place these wooden boxes. I'm going to demonstrate that with the detailed procedure. Okay, so let us take a new project, means new project directory, that is go to wizards, new project directory. Here project name is four-wheel robot, you can say, and click on add a rectangular arena. Finish. If you want to have a larger space, then you can go to the rectangular arena, floor size 2 by 2. Okay. Next is, even I'll close this one, this is a previous one. So now there is no controller, I need to add controller. So first we need to build the structure. Okay, so here this is what the final structure required, right? So the body, first the blue color is the body dimension is in next direction, that is 0.1 meter, y direction 0.05 meter, z direction 0.2 meter. Okay, so that one we go to the, click on the rectangular arena, then click on plus. First base node, in that base node take a robot, then in the child, that is children, click on plus. That is transform. Under transform, again children, click on plus, shape, after shape, the dimension, that is geometry required is box. The dimension is given, that is x 0.1, y 0.05. Next is z is 0.2 meters. See, right now console I'm going to disable it. This is a structure, that is body dimension is x is 0.1, y is 0.05 and z is 0.2. Now actually the in y direction half of the body below the floor, half of the body above the floor. So for this, see, when model is ready, at that time I am going to increase the rectangular arena floor size more, but right now let it be 1 by 1. Okay, so that I can see here, see, below the floor also some part is there, that is half part. Okay, so I need to lift in y direction, that is half of the material I should lift in y direction, because here coordinate system is red color is in x direction. So for that, go to view, optional rendering, show coordinate system. See here, x means red color, that is in this direction, y means upward direction, z, this is blue color is the z direction. Okay, now I need to lift upward, so go to the translation of this, see, transform base node, we need to rotate, that is why we have taken transform. Okay, go to translation, y, what is the entire means in y direction, what is the dimension? 0.05, that means 0.025 I need to lift upward. So this makes the body sits on the floor exactly. Okay, since we want to have a movement, so if it sits exactly on the floor, it will have a friction, it will not move. So I will lift the body by 1.5 centimeter more, that is a clearance between the floor and the body. So I will add 1.5 centimeter, that means total is 0.04. See, uh, you can see that there is a gap between the body and the floor. That is called clearance. Okay, 0.025 is the portion below the floor. I lifted that, but extra for 0.015 and giving extra so that it becomes 0.04. So that is the clearance between the floor and the body is 0.015. I think it is clear to you. Next is, so body is there, but we need to add color also. So for that, go to appearance, double click on the appearance, base node, PBR appearance, then add. Here color, I want blue body, so make red 0, green 0. Okay, and then go to roughness, you add by 1, metalness 0. This is the body. Now once body color is done, then dimension is done, then we'll take a shape. The name of the transform node I will take it as a body. Okay, and you come down and then bounding object, go to bounding object, double click on it, then use body transform, physics, double click on it, then add. Okay, so this is done. Now body is done. Now we need to add the wheels. Okay, so wheel 1 we're going to design. That means go to body transform and then plus mark, then hinge joint, because we are going to fix a motor. Okay, wheel with motor, so take a hinge joint, and joint parameters are important. Double click on it, then add, then device, double click on the device, rotational motor, add, then name, can call it as, this is a wheel 1. Okay, end point where we are going to fix the wheel, so double click on it, base node, solid, then go to children, plus sign, then shape, add, geometry, double click on geometry, cylinder, next go to geometry of the cylinder, height is 0.2, that is 0.02, sorry, that is 0.02. Okay, next is radius is 0.04, that is because it's not visible, because it is above the floor but below the body. Now appearance, double click on it, PBR appearance, then color I want red, so make green 0, blue 0, then metalness 0, roughness 1. Okay, now wheel 1 position, it's not visible, right? So wheel 1 position we need to adjust, that is go to translation, in translation x value is 0.06. Why? Because the body total length in x direction is 0.1. Okay, so when you divide by 2, so that becomes 0.05. So we are taking 0.01 extra so that there will be joint. Okay, 0.04. See, now it has come out, and z also 0.05. Now the position is correct, but orientation is in horizontal. We need to rotate by 90 degree. So go to rotation, x0, y0. In z direction make it 1. So in z direction, with reference to that, rotate by 90 degree, that is 1.57 radians. Okay. See here, this is the first wheel. Now the position is completed. Now go to the shape here, name it as wheel, because we are going to reuse it. Wheel, and then come down, bounding object, use wheel, physics, add simple physics, and after that in the definition you add wheel physics. Okay, press enter. Now it's very important, this one. See, translation, what is there? 0 0.06, 0 0.04, 0 0.05. This value should be same in the, go to joint parameters, in the anchor position it should be same. So 0.06, 0.04, 0.05. If you miss this anchor position, then body will move in a different way, unexpected way. That is why it should be same. Whatever translation value is there, it should be same here also. Fine. So that is about inch point 1, that is wheel 1. So wheel 1 is completed. In the same way we should complete for wheel 2, wheel 3, wheel 4. Okay. Now we are going to design the wheel 2. Means okay. Now again go to inch point, plus mark, same procedure. You take again inch joint or inch joint, then joint parameters, add device, rotational motor, name of the motor is wheel 2. Okay. Go to endpoint, double click on endpoint, base node is solid, then children, plus mark, shape, but here you don't have to shape again, okay, because already taken. Go to use, then wheel shape. Okay, so now already wheel is added here. The position, we go to translation, and position is minus 0.06 because we want it in other side. Okay, that is y 0.04, no change, z no change. Okay, but orientation, if there is rotation, we have to do it. That is x0, y0, z minus 1, and rotation of 90 degree, that is 1.57 radians. Okay, so this is wheel 2, wheel 1, wheel 2, next wheel 3, and next wheel 4. So again, don't forget here, that means go to bounding object, use wheel shape, but in physics you have to take the wheel physics, which is stored already. Add. Then next, whatever translation values is there, same thing should be there in the anchor. So go to joint parameters in the anchor, minus 0.06, then 0.04, next 0.05. It should be same. That is wheel 2. Next is go to again inch joint, plus mark, base nodes, inch joint, joint parameters, double click on it, add. Next is device, double click on it, rotational motor, name of the motor is wheel 3. Okay. End point, plus mark, solid, children, plus mark. Already wheel is there, so go to use wheel. Now the position, that is translation, wheel 3 we are doing it right, that is x is same, that is wheel 3 means this one, that is positive x 0.06 and 0.04, now minus 0.05. Okay, now rotation y0 x0 y0 z1 and angle is 1.57. Okay, that is a wheel 3. And bounding object, use wheel physics, wheel physics. And don't forget the anchor values. Go to joint parameters. There, whatever translation is the same thing it should be 0.06, 0.04, minus 0.05. That is done. The wheel 3 is done. Next is again plus mark, base node, solid, sorry, this is wrong. Go to inch joint, plus, click on plus. Again you have to take inch joint because that is we are doing wheel 4, right? Inch joint, joint parameters. Next device, double click on device, motor, name of the motor is wheel 4. Click on endpoint, double click on endpoint. Now take solid, under the solid, under the children, plus mark, and next that is use a wheel shape, but it is not visible because coordinates position is not proper. Go to translation, wheel 4 is minus 0.06 and y is 0.04 and z is minus 0.05. Okay, but rotation we have to make it, that is x0 y0 z is minus 1 and that is 1.57. See, all 4 wheels are ready, but now still it is not completed. Bounding object, use wheel shape, physics, wheel physics, and after that don't forget the anchor position. So here whatever translation values is the same thing should be there in the anchor. Minus 0.06, 0.04, minus 0.05. I think we have done almost means all 4 wheels. Now click on the in joint 4, that is again plus symbol, because we need to add now the sensor position. Okay, 2 sensors are there. Go to base node, then distance sensor, add. The distance sensor, go to children, plus you can take shape, under shape, geometry, double click, then box, that is dimension is 0.01 by 0.01 and 0.01. It's not visible because it is inside the body. Appearance, double click on it, PBR appearance, then color, I want it in red, so other color should be 0, roughness 1, metalness 0, and name of the sensor is DS left, distance sensor left. Now the position is not proper, that is go to translation. So in the translation, x is 0.01 and y is 0.04. One minute. And z is 0.1. So you can see a projection here. This is the nothing but distance sensor. Okay. If you want, you can keep a little upside because it is in, right now it is in center. 0.04 means it is in center. You can take around 0.6. No, it is too much. That is 0.05. Yeah, 0.05 is also good. Or let it be like 0.04, not a problem. Okay. And rotation, it is now actually, if you enable the sensor rays, go to view, option rendering, show sensor distance rays. That rays, it's showing in this direction. So that rays should be exactly perpendicular to the vehicle front face, right? So this direction should be changed. Sensor working in this direction, but we want in front face. So for that, we need to go to the rotation. There x0, y1, z0, then angle is minus 1.87. 1.57 is 90 degree. Again 0.3 radians extra we have to take it. So this is in this direction. No, I want it in outward. So it should be minus 1.27. See? It's not straight, but there is a 0.3 radians angle extra is there. So this is in this direction. So this is okay for me. And that is about distance sensor. So again we have to take the plus sign here on the distance sensor. So again go to base node, distance sensor. 1 minute. In distance sensor, yeah, object bounding is there, so click on that. Still sensor 1, there is a okay. So we need to save this shape as a sensor. Still we are working on left sensor. So the shape named as sensor. So then go to bounding object, go to use sensor, physics, and simple physics. That is about distance sensor left. Now distance sensor one more we have taken. So go to children plus. Now you take the shape, sorry, distance sensor already taken, sorry. This is, instead of go to, already we have stored the sensor, right? So there, children, shape, sensor, you take it. So now sensor is added. Now the position of the sensor is not proper. So that is second sensor is, that is sensor left is x is 0.02, is positive. No, it should come to this position, right? Minus will be minus. Yeah, so this is x1 means x is 0.02 minus, so it will come to this position in x direction, and y is 0.04, that is in center, and z is 0.1. Okay, from here to here it has moved 0.1. Now if we check on, first of all, distance sensor name, this is ds underscore right, that is the name, and go to view, option rendering, show, again show the distance sensor is, so it is again in this direction. So we need to rotate the beam. That is x0, y1, z0 minus 1.27. Let us see. It is coming, but again it is this way. I want in other direction, right? Means after 90 degree, then again 0.3 radians. So this one rotation on this one is 1.87. Yeah, this is the correct value. Let us update it in the wheel dimension is, height is 0.02 actually, that is required to be updated. And wheel to transformation is minus 1.87, that is sensor, second sensor, and first sensor is minus 1.27. Left sensor is 1.27, left sensor is 1.27. Okay, and actually it was correct. this to 7. Fine. Now we have completed the vehicle. Tags also done. This is wheel 1, wheel 2, wheel 3, wheel 4. Okay, perfect. And save it. Actually, in between you have to save. After every hinge joint you should save the work, otherwise sometimes your work will be lost. Okay. Now it is fitting, means it's sitting on the floor, so it is perfect. Vehicle is perfect. Now we need a controller. So how to add controller? Go to wizards, new robot controller. Next, C language, we are using it. My controller. Okay, this name is okay for me. Next, and click on this. Already it is on, so finish. This is a sample, means built in, some code is written there, but we're going to not use that. So first we'll move robot forward, so 4-wheel drive. This is a code for continuous forward movement. Infinite, see here, infinite position. It is continuously moving, so it's not going to detect the object. Sensor is not added. Sensor we have added physically, but not in the code. So save it, then build, and before that go to robot, search for controller. See here, controller void means nothing is there. You can double click on it, go to select, then my controller is my controller, then save. Now controller is linked. Now you have saved the program, but you have to build it. Reset, then go to, actually rays are not visible, so that's okay. It's in this problem, in this case, not required. If I click on start, now it is moving. Actually it's moving forward continuously. Perfectly it is moving. Okay, so this is the logic, this is the code. Note on the code, you can execute it in the laboratory. Stop, reset it so that it will come to home position. Now I'll take a different program, that is forward is okay. Now moving backward. I've changed the program, then save, rebuild or build, then you should wait. Reset, run, so it is moving backward continuously. Stop, reset. Now we other programs, that is now turning left, should wait till it comes reset, run. On the same place it will turn. It's like a spinning action. That is turning left, now turning right. Reset, run, turning right. Okay. And now next experiment is it should move forward by 0.2 meter. That means position control. Control A, delete, Control C, sorry, Control V, then save, build. This is the logic. You should wait till reset comes, then reset, then run. Moving by only 0.2 meters. Okay. Now the last program is backward by 0.2. Save, build, should wait, reset, run. So goes backward by 0.2 meter and stops. Okay. Now the last one is obstacle avoidance. So now go to the program, change the program, save it, build it. It should wait till reset comes. Reset and go to view, optional rendering. Go to view again, optional rendering, show light sensor, so distance sensor, race. Okay. Now let us see. Now is here no obstacle is there, but wall itself is obstacle. See, it's now it is turning right. Okay. Now we can add some obstacles actually, so that I will show you how to add it. So go to stop, reset. What I'll do is I'll take go to the rectangular arena. See, and save option is there, just save it, and then go to the rectangular arena. Floor size is 2 by 2. I will take it. Okay. Save it. Next is click on the robot, plus sign. So there, proto nodes, objects, factory, containers, wooden box. So that wooden box is very large in size. So go to the size. You can take 0.1, 0.2, y, z. I can take it 0.1. Okay, but it is above the floor. First I'll take it in z direction some distance. Translation, y I'll make it 0 so that, okay, not 0, it is 0.15. Okay, I'll make it on the floor. That is 0.1, exactly on the floor. And height also you can take 0.1. No, it is, okay, let it be 0.15, and it's not on the floor. Fine, it is 0.2. Some gap is there. Wait a minute. Using this arrow, green color, I'll make it to 0. 0 mm. So now exactly on the floor. Okay. So this boxes I can add, save it. After save, then copy wooden box, Control C, Control V. 3 and 4 boxes I'm taking it, and one by one I can take out from here. Can place wherever you want. One more is there. Okay, so this is what the obstacles. Save and then run. Actually it is not sitting on the floor, some gap is there. 1 minute, I'll make it translation, CO5. Yes, that is there on the floor. The translation actually it is 0.05. And last one, and this one, translation 0.05. Then save. Now you can run again. Okay, yeah, this is the final output should come. So we have discussed around 6 experiments: continuous moving forward, continuous moving backward, then turn right, turn left, then move distance by 0.2 mm forward, sorry, 0.2 meter forward, again 0.2 meter backward. And 7th one is like obstacle avoidance robot. So totally around 7 experiments in this we have discussed. So that is 4-wheel differential drive robot. So if you have any questions, put it in the comment section. Okay, thank you everyone. Thank you for watching this.